let's start with my little house. This is my street in Anywhere, USA. I own kind of a small house right here. On my property, I actually have a detached garage, and that's where my music room is located. It's sort of on that corner of my property, and it's a fair distance to the neighbor to the east, as well as the neighbor to the west. And to the north, this is actually a multi-unit residential property. This is a driveway to give access. This is parking, and the small apartments are actually located back here. So in terms of distances, from my garage at the corner there, even to the property line of my next neighbor, this is really their house is probably 60 feet or so away, 50 to 60 feet. And the property line is probably 25. We'll put that there. On the west side, it's a good 70, 80 feet as you go across that street. And to that north, we zoom up a little bit. You're still 40 to 50 feet before you hit where someone actually lives. So there's actually a kind of a unique advantage to my property in that my music room is detached from the house, and it's actually a fair distance from everyone. I've also made an effort to not play too late or not play too early. And there used to be a renter in this property who I had a conversation with. Hey, I'm a drummer, and I like to play. If you ever have a problem, give me a call. And I had that same conversation with the new owners that moved in maybe about 2 years ago. And I've never had a complaint about this, but I've also been a little self-conscious. And, I have kind of made my own rule that I don't play before noon and I don't play after 7 p.m. And that's worked out for the last 4 years or so. But when I was looking at my space, there were a couple of very basic improvements that I thought would help improve the sort of acoustic control as well as the use of the space. And then, as I started looking into it and doing the research, I thought, there's an opportunity here to make some significant improvements that would make it a lot easier to possibly play outside of some of those hours I had pre-established, as well as just future-proof any issues. I think all of us as drummers, we get a little bit nervous about, neighbors. It's a kind of a noisy instrument. It's sort of a blessing and a curse. Everybody wants to hear the drums, but then again, nobody really wants to hear the drums, especially if they're hanging out in their living room. So this project is really focused on implementing a few best practices in terms of soundproofing or acoustic control. That would be different than sound treatment or improving the response of the room inside. So what I would encourage you to do with this is, first of all, do your research. So I'll show you a couple of books and resources that I've used in planning my project. One here is a book, How to Build a Small Budget Recording Studio from Scratch by Mike Shea and F. Alton Everest. This one had a lot of interesting information, a lot more about sort of the engineering or acoustic engineering and some of the principles. It has also a lot of information about acoustic treatment and some basic information about acoustic isolation or soundproofing. But another resource that I thought was a little bit more pragmatic and a little bit more focused on, okay, how would I actually build something, or what are the materials that really make a difference? Or as Rod Gervais here points out in his book, Home Recording Studio, Build It Like the Pros, is what is the right material and is it in the right location? And this was kind of an interesting resource because it covers across the whole construction set of trades, whether it's carpentry and framing, electrical, HVAC, and some of those other pieces. And he also gets into acoustic treatment, which is kind of, again, treating a space to improve sound inside of the space. But one of the things that I think Rod brings to the table is really that construction background. There's a lot of helpful diagrams and drawings and topics there that are, again, really pragmatic into how to physically do something. I personally come from a construction background in terms of engineering and design, but not necessarily all the trades. Some of my professional experience is in specific areas where other areas I don't have as much experience. And there are areas where I don't have as much experience in terms of physically doing it myself. It's easy to put it on a drawing. It's a little bit different to actually doing it. But this does dovetail very nicely into the idea of planning. And that's one of the things that I think is incredibly important for any project, is thinking about, okay, how am I going to plan this? Now, I would encourage you to look at doing drawings or sketches. And I think those are a really easy way to kind of put everything on a page, lay things out, and find out what makes sense before you're, cutting drywall and cutting 2x4s and all that stuff. And there's a lot of ways you can do that. So right here, this is AutoCAD. I'm just showing this in a free viewer that's looking at an AutoCAD file. Now, not everybody can have access to AutoCAD, but I started here because this is just sort of the 2D representation that you might see on a set of plans. Very basic. It's kind of the starting point for design. And so let's talk about my garage. So we talked about my music space. My music space is here inside of this garage. It's about 180 square feet. It's very simple. We have, you can come through here to get into the garage area. There's a set of double doors that bring you into this room. There's a window in the east wall. There's a small window in the south wall, and there's an exterior door in the west wall that takes you out into sort of this porch area. Inside, it's very simple. It's just a box. We've got a few electrical outlets. There is the electrical distribution board for the garage is located in this space. And we have some surface-mounted lighting in here. Very simple. You've seen it in a lot of my videos. But it's nice and, again, conveniently located away from the house and relatively distant from the neighbors. As you come through this space, you come into the garage area that has sort of a traditional roll-up door, some very basic lighting. It used to have an open slat construction on the south side. I did a project last summer to frame this all in. It's got sheetrock and some storage here, so that kind of helped a little bit on that south side. So this is really where we're starting with in terms of the work. So in terms of planning, looking at your space, what do you have? And you can start to draw it out and test ideas and see what makes sense to you. So this other drawing here, same application, AutoCAD, again, just working in 2D, and we're just doing line drawings or sketches. So here I can start to actually build it on paper before I get out and try to build it in real life. So concept I wanted to do was a room within a room. And when you start looking at that, you start to think of, okay, how would I actually do that? If I have the exterior wall, which is represented by these two lines, what is the impact of framing up a wall inside of that exterior wall? What does it impact my floor space? Once I put in studs and I put in gypsum wallboard finish, and I try to keep a certain distance separation from the other wall, again, on paper, you're able to start planning out what is the actual impact and how's this going to work. And here you can see what I've actually done is, again, built it on paper first. So I'm laying out studs. I'm working through, there are a couple of options you can go with stud spacing. These are for the walls. Common spaces you'll see are 16-inch on center, 24-inch on center, and there's even one 19.2-inch on center, which I've never seen. Thinking about openings, where would the door go? What sort of framing does the door need? What clearances does it need from different things, and how does that impact your space? This is a good 2D way to start thinking about it. Now, a couple things. One is not everybody has access to AutoCAD, although there are some freeware versions, but almost everybody has access to pen and paper. Even if you don't want to do it on a computer, you can look at laying things out and testing ideas, although that's a little bit, can be time consuming. But one tool I would highly recommend for everyone to look into is Sketchup. Sketchup is very similar to AutoCAD in that it allows you to draw things, but this is essentially a 3D modeling software, and it's incredibly easy to use and it's very intuitive. Now, there is a free version you can get online. SketchUp has moved to sort of a paid version that you can access via online, and that's what I have. But the free version is very similar to the paid version, and I think most basic projects could probably get tested and modeled using the free version. But what you have here is that same concept of AutoCAD in the sense I'm doing drawings, but I'm actually doing this natively in 3D. This is a model that I can move around, I can test, I can measure different distances between elements, I can check things. There are ways to, again, build this on paper, or here, build a model before you get out to site. And I've taken time to actually do just that, in the sense of, this is a stud, this is where it goes, this is the distance it's going to need to go from the next stud. Where's the wall plate, bottom plate? How do the top plates sit? How do the two top plates mate with each other? Those sort of things. And what that does is it allows you to test ideas and to see what something's going to look like before it happens. Now, what this is representing in this model here is kind of what I have already. So I didn't model everything, so that I didn't bother modeling the existing exterior door where you walk into the garage. This is the garage door, roll-up door that's here. This is that existing exterior door in the west wall. I didn't bother modeling the windows because I'm actually going to be removing those. So I'm starting with this. This is kind of what I have. I threw a drum set. Look at that. That's pretty cool, right? I threw a drum set right in the middle there just to kind of give you some concept of space. So this is what I'm starting with. And again, this allows me to sort of, I'm a very visual person. I love the fact this is very visual, very easily to look at, to test, and actually using this software is super simple, okay? So if I'm starting with this, let's say, okay, well, that whole idea of building a room with a room, what is that going to look like? So let me pull up so that's what I've done. So here in my SketchUp model, I've gone in and I've framed every member of my new wall. So this is an existing wall that comes through here. And this is where we're going to be building this second wall, which is to help isolate the music space from the rest of the building. And the existing framing is 16-inch on center, which is pretty common. This is a load-bearing partition. The ceiling joists rest on this wall here. My new wall is going to be framed at 24-inch on center. That's done purposefully so that a couple things, it's less framing for cost, and also in terms of acoustic response, less framing provides better isolation. Because there's more of an air gap or insulation that is helping prevent sound migrating from this wall construction through this gap to the next wall construction. Each one of these pieces of frame is essentially a short circuit where that sound can excite the mass and travel through that other mass. And really this whole concept of the wall, the room within a room, is sort of the mass spring mass concept. And that's, you got to have a mass wall, a spring, which is this airspace in between, which also has insulation inside these stud bays, and then a mass on the outside. And really that's kind of the key, and what you'll see in Rod's book, and you also see through a lot of tutorials. Don't be fooled by products that say they'll magically reduce noise in terms of acoustic control. There's a big difference between control and treatment, but in terms of acoustic control or soundproofing, mass is literally almost the one thing that will do it. Okay, you can't magically put egg crates on this wall and expect that you're going to prevent sound from traveling through this construction. So again, in terms of planning here, I've built literally every 2x4, and I can build it in this model before I ever start on site. So we talked about a room within a room. We have walls framed up here, 24-inch on center, and they are on the existing concrete slab. Now, one thing I did look at a long time ago was some concepts where I could use, I would build a floating floor. What I have here is my original concept, and I'll just kind of show you this in 2D. Again, I used AutoCAD to sort of draw this. My idea is very similar to what I'm going to be presenting here is my current design, but the difference is that this design, I actually added a floating floor, and that floating floor would be another way to help isolate the room with the room from the slab. And I'll show you another set of images that make this a little bit easier to follow. This is my original concept, and really what you start with the current space that we have, and this is my idea for the floating floor. I looked at a couple of different constructions, I watched a lot of YouTube videos, I read some books, and essentially this would have been a framed floor that would sit on rubber isolators. This specifically was going to be a product by Oralex called U-boats, but essentially they provide an isolation for that floor framing from the existing slab. And then inside of the slab I would put rock wool insulation, and this construction here with the purpose of helping isolate the room within a room from the existing slab. Now this is a lot of construction, there's a lot of materials here and a lot of cost, especially these small isolators. There's a couple different products and a couple different approaches, but these specific ones weren't cheap, you know, $3 or $4 each. So when I looked at this, you know, one big thing was in Rod's book, it really talked about floating floors, and to sum up his conversation was basically you will never get enough mass for it to be effective, and especially in this in terms of lightweight framing. And if it's a slab on grade, this doesn't make any sense. There's not enough mass, and in some situations this can actually make it worse, because you essentially create this sort of almost like a drum, and there's some complications here. So again, going back to my original idea was you'd have that floating floor, you'd frame up your walls. I even looked at doing 16-inch on center internal framing, and you would have your floating floor, you'd put your subfloor on top of that, and then you could put whatever floor finish you want. I was going to put an LVT product, and I'll kind of leave that there. So that's one big difference between my original set of ideas and then sort of my current set of ideas, and especially influenced by Rod Gervais's book, and some other information and research I've done. I think YouTube is a great resource, but also it's full of like just homebrew and like maybe not completely valid approaches, and some great ideas, but you know, seeing it in print by an experienced studio designer, I think is a lot more reassuring than you know, someone's YouTube video. And I understand the irony in the sense of you watching this video. So again, I just want to kind of present these ideas. So that's a long introduction to say my intent is for the room within a room to be installed on the existing slab. Okay. So now we've built the walls, 24-inch on center. There's a gap. The gap kind of it varies, but it's between 1 inch and 2.5 inch. Obviously, there's no finish shown on anything right now, so there's, you know, it's about that. But these are physically separated from each other. So I'm going to start maybe with the sheetrock here while we're still on the walls. Inside the garage, I'm actually going to demo, because I replaced this wall essentially inside the garage, and I'm going to demo this sheetrock here, clean this up, remove the window there because I want to add insulation. There's no insulation in this wall right now, so that comes off, and I'll be replacing it with 2 layers of 5/8 inch drywall. And on this garage side, it's just going to be that. So I'll get to the inside of the music room here in a sec. And I'm going to replace that same sheeting on this wall. You know, by this point I would have replaced the sheeting on 3 out of the 4 walls, and these are actually, there's not much wall on this side because of the garage. So I thought, you know, I want to clean this up, and there's a couple things I want to do, clean up the electrical and stuff. So I'm actually going to pull this sheetrock off and do this. But this is just going to be a single sheet over here. And I don't even think I'm going to insulate this. So, okay, so that's these existing walls and how we're going to do a little bit of modifications to it. One of the things also is that in terms of that double door, what you'll find, and you'll see in the books, and you'll see in a lot of tutorials, is obviously doors and windows are kind of real leaky sources in terms of noise control. So although the double door concept is beneficial for moving large things in and out of this room, I just don't think it's worth it. So I'm going to reframe this or frame it in for a single door on the existing wall. And you'll see it'll be a door here. On the inside, in the internal room within a room, there will be another door. So you're going to have a double door set up. And you'll see that throughout the resources. You'll see that all over YouTube. It's quite common that you room within a room. Where really in Rod's book, there's 2 big approaches. You could have one massive door, or you could have the 2 separate doors. And there's some details there. But inside here, we're going to have the new framed wall, and I haven't modeled it, but I'll talk about insulation here in a second. But on the finish here, you're going to have 2 layers of 5/8 inch drywall. The seams are not going to be lined up with each other. So as you can see, it's a little bit, this detail here, you know, this is kind of modeling where the seams are, and they're staggered. This will all be acoustically sealed in terms of using a purposeful sealant throughout, and then two layers of 5/8 inch drywall, and in between those layers I'm going to put the green glue. And green glue, you're going to see tons of videos and resources on that. That's essentially a compound that never fully dries. It is intended as a dampening material. So the idea is that as sound waves strike this construction material, they vibrate this material. That physical vibration gets dampened by the green glue that's in between these 2 sheets of drywall. That mechanical energy is converted into thermal energy, which is absorbed by the wall. And again, it's about a process to help, again, prevent sound from escaping this construction. Green glue is not cheap, so I've been kind of looking into that and reading some more resources. But essentially you have a sheet of drywall, green glue, another sheet of drywall, you're framing, and then in this stud bay, and let me pull this, turn this off here a second. In this stud bay here, you know, this is the existing air gap new. In the existing, we're going to put up a mineral wool product that's going to be an R15 mineral wool. Then you're going to have an air gap, and then we're going to have the rock sole or rock wool safe and sound bat inside the stud bays in the new construction. So you have exterior cladding, which will take effort to go through and seal that up as best we can. We're going to add R15 mineral. There's an mineral wool. There's an air gap, and then you hit rock wool safe and sound in the new wall. Then you have 2 sheets of drywall, and in between of them you've got green glue. So effectively, you know, this is a 4-inch or a 3.5 inch plus a 2-inch plus a 3.5 inch. You're sort of a 9 plus the exterior cladding. You're kind of getting up into the 10, 11, 12 inch in terms of overall wall thickness. And again, with the mass spring mass concept for that. That's the sort of floor, the walls, and how the walls relate to the exterior walls. And then let's talk about the ceiling here. So the ceiling, again, is going to be independent from the existing ceiling. The existing ceiling, there are ceiling joists that come across, they overlap here at this load-bearing partition. Up in the attic space is minuscule. There's just a little bit there, not a lot. But down below, you're going to have on the top, the ceiling joists, new ceiling joists will bear on the new partitions or the new walls, room within a room. You'll have new ceiling joists. And then on top of those, and I won't show it because it just cover all this up, but you're going to do a very similar construction technique for the ceiling. So you're going to have your 2x4 ceiling joists. You're going to have 2 layers of 5/8 inch drywall. And then you're going to have green glue compound in between those sheets of drywall. And then above in the space between the new ceiling and the existing ceiling will be safe and sound, rock wool safe and sound. Now, in terms of existing construction, you have a single layer of sheetrock attached to existing ceiling joists that bear on these walls. And then above that, you have blown-in insulation in the attic. Now, I had wrestled with the idea of maybe I demo all that existing ceiling and I redo the insulation there. It's just a lot of work and there's a lot involved, and I just kind of like, is it really even worth it? You know, there's a couple different approaches that I've seen that were done. I saw someone basically, they put a vapor barrier in the existing ceiling joist space to hold rolled insulation. So that construction was rigid drywall, 2 layers, ceiling joists, a vapor barrier, insulation, then the attic space. And that idea was to reduce the sort of impact of the kind of a bit of a drum effect where you have 2 rigid layers too close to each other. And the overall construction becomes a bit of a drum. Rod talks about that a little bit in his book. And one of the big things I talked about at the beginning of the video was, you know, not only is it about the right materials in terms of mass, but also where they're located. And what was interesting, what Rod showed in his book was you actually get a better overall performance if there is no drywall on the inside face of this new wall. So you go from mass, spring, mass, as opposed to mass, spring, mass, spring, mass, because that's a proximity between those rigid layers. You get a lower sound transmission class, which is a general metric for evaluating the effectiveness of reducing sound transmission through a wall construction. You actually get a worse one by putting the sheetrock in here. And that situation is what you end up with the new ceiling. You basically have your new drywall for your new ceiling, you have a space, and then you have the existing drywall, and that kind of mimics that that less performance. But I think in terms of constructability, it's probably a better approach for me. And what's nice, again, what I highly encourage is that you're thinking about that before you ever cut a hole, before you ever cut a 2x4. Building it virtually is going to save you time, effort, and you can see where the potential mistakes are or where things need to be detailed before you ever get to site or you ever start spending money or messing with stuff. Okay, so we went over the framing here, the wall. I'm going to actually turn off that ceiling framing. All I'm going to show on the floor here is we're going to put down a kind of 3-in-1, which is a vapor barrier, a little bit of insulation, and then I'm actually going to put in some LVT flooring. And I haven't modeled it, but essentially you're going to have the 2 doors here to help separate, and there's a lot of devil in the details when it comes to doors, and I don't think I'm going to cover that because I haven't modeled that, but there'll be some more information on that I've found. I think Rod's book is really helpful with that, and there's a couple of YouTube series that I think are real helpful with some ideas here. But most of all, what you'll see is the big effort is in preventing any sort of air passage between these spaces.